Hello, welcome to another video. In this video, we are going to solve integral sin inverse x over x squared dx. For remove sin inverse x function from this integral, we can give a substitution. We can get t equal sin inverse x substitution. Then we can write t equal sin inverse x. Differentiation with respect to x, we can write dt over dx equal differentiation of sin inverse x, we can write 1 over root 1 minus x squared. Then we can subject dt as 1 over root 1 minus x squared dx. Then root 1 minus x squared dt equal to dx. Then we can subject dx as root 1 minus x squared dt. Okay. Now we know t equals sin inverse x, so sin t should be equal to x, then x equal to sin t. In here, instead of x value, we can give a substitution again, x equals sin t. So we can write dx as root 1 minus sin t perfect squared into dt. Then dx equal root 1 minus sin squared t into dt. We know according to basic trigonometry equations, 1 minus sin squared t should be equal to cos squared t. So we can write dx as root cos squared t. Root value of cos squared t we can write as cos t. So we can write dx as cos t dt. Now let's move to integral part. Instead of sin inverse x, we can write t. Instead of x, we can write sin t. So we can write this integral as integral t sin t perfect squared. Instead of dx value, we can write cos t dt. Now integral t sin squared t cos t dt. We know sin squared t should be equal to sin t into sin t. So we can write this integral as t into 1 over sin t cos t over sin t. We know 1 over sin t should be equal to cosec t, and cos t over sin t should be equal to cot t. So we can get integral t cosec t cot t into dt. To simplify this integral, we can use integration by parts method. We know integral of cosec theta into cot theta equal minus cosec theta. So in here we can give priority for cosec t into cot theta. Cosec t into cot t integral we can write as minus cosec t. We can write t term as it is t. Now minus integral minus cosec t, differentiation of t equal to 1 into dt. Minus cosec t into t plus integral cosec t dt. We know integral of cosec theta should be equal to minus ln modulus cosec theta plus cot theta. So we can get the answer as minus cosec t into t integral of cosec theta equal minus ln modulus cosec t plus cot t. Instead of t value, we can substitute t equals sin inverse x. So we can get final answer as minus cosec sin inverse x into sin inverse x minus ln cosec sin inverse x plus cot sin inverse x plus c. Here c is an arbitrary constant.